Okay, so hello guys. So here's the next question for the problem of the day. That is count of substrings containing every vowel and k consonants too. Okay, second version of it. Okay, so what we have to do basically, we have to count the substrings. Okay, total number of substrings that will contain all vowels and exactly k consonants. Okay, let's just understand this question here. Let's just take this. Okay, so here, and let's just take this k. Yeah, so here k and here's the string. So what we have to do basically, we have to find the total number of substrings that can be found from this string, and in which there is basically all the vowels are present. Okay, and exactly k number of constant are present. So these two conditions are there, so that we have to generate the substrings. So if you see this example, in this a e I o u, sorry, u is not present. Okay, so simply this will never generate a valid string according to this question. Okay, because here a u is not present, so all vowels can not be basically possibly present. Okay, so that's why here output is 0. So if we take this, let's just make u here. Okay, so if you just see that I have written u also here, so this time this contains all the 5 vowels. Okay, but if you see, if you take any substring that like from this to this, only one vowel should contain, like k is 1, so only one constant should be contained. Okay, so if you create any substring now, the valid substring cannot be basically calculated, cannot be created now also, because if you see substring that this is from this or this or this. Okay, but substring cannot be, because q is twice. Okay, and the constant should be only 1. Okay, so if the q was like if q was like, let's just take here q was 1. Okay, so if you see, the valid substring can be possible. Okay, so if you see, this is the valid substring. Okay, if this was the string, so only one this substring can be possible. Okay, so if you see one thing, it doesn't matter how many vowels are there. Okay, like u can be here 2 or 3. Okay, or a could be like 2 3 4, any. Okay, a e I o. Vowels number, basically frequency of vowels doesn't matter, only the consonants should be only this k times. Okay, like here k is 1, so constant should be 1. So if we see in this, so how many valid substring with this k can be possible? If you see, so 1 is this. Okay, a e I o. Okay, and 1 could be this. Okay, like if we add from this a. Okay, and this a, basically you can if you see, this is the main valid string, and after this this vowels are repeated, so simply we will add the frequency of vowels that are basically repeated till the next constant is not appeared. Okay, because only the case in constant the valid string can be basically violated if the basically all 5 vowels are present. So simply in this, one thing is that if we get a valid basically window or substring, like if we take this, so the valid substring is this. Okay, so if we get one valid substring, we can simply get another valid substring. If we see, like here this let's just draw it. Okay, so this is the valid substring. Okay, this is the valid substring. Okay, yeah, valid window. So simply we can extend this valid window to till next constant is not appear. So all the basically vowels that are present between the next constant are basically valid substring. Okay, can be valid substring. Okay, so here's the main thing is that no basically constant more than k can be there if there are all vowels. Okay, so this is the main thing. So this question can be like so the main key thing is here, that is we have to only get k substring. Okay, sorry, k constant. Okay, so if you see, if we find total number of basically at least k constant in the substring, like if we say, if we found a substring that has at least k substring, like more than, it can be possible more than k but not less than k, at least k. Okay, and if I, let's just draw a number line. Okay, you will get from there. Okay, like let's see, here's the point. Okay, here's the point where k, exactly k substrings are possible. Okay, basically exactly k substring is possible here. So if you see that if we see that at least k can be from here. Okay, more than k. Okay, at least k means from k to more than k, not less than k. Okay, so all the substring with more than k or k are possible from this. Okay, and if we find exactly k plus 1 substring. Okay, exactly k plus 1 substring, at least k plus 1, that is from here to here. Okay, so from here to here. Okay, at least k plus 1 substrings are also fine, like okay, and when we, if we see these two differences. Okay, if we at last subtract this at least k to minus at least k plus 1, then simply we will get exactly k substrings, basically exactly substring with k consonants. Okay, you got it. So we will find at least k substrings. Okay, all the substring with basically k or more than k consonant, and next we will find all the basically substring with k plus 1 or more than k plus 1 substrings, basically constant, and then we will subtract this. Okay, so you got the approach. This is the approach. Okay, so basically we are seeing that we have to use sliding window to do this. So you mainly you got the approach how basically we are going to do this. Okay, so after this the only code thing is basically important. So I will tell you in a brief what we are going to use. We will use a hash map, that is vowel count. Okay, vowel count, that will simply take care of the total frequency of the vowels basically in the window. Okay, and we will take a constant count, that will take care of the constant. Okay, and by this we can basically form the answer. We will see in the code. Okay, so you got the meaning, mainly basic approach. Okay, so how, what we are going to do. Okay, so let's just go on the code and we will see how the code is working. So that's the, okay, so here's the Leetcode. Okay, so let's just code it. Okay, so what we are going to do, we are going to create a function that is return. First we will just return the function that is at least. Okay, at least k, we will first we will found the k times. Okay, just let's write word k. At first we will form the total number of at least k constant substring minus, and we will return at least word k plus 1. Okay, so that's the main thing. Okay, then we will simply create, we can create a function that is at least. Okay, so this function will simply return the total number of basically answers, valid substrings. Okay, long, that will simply contain long. Okay, long at least, and it will simply contain the string word and int k. Okay, so let's just make it. So simply first we will take care of some variables, that is num valid substring. Okay, total number of substring, valid substring, that will simply 0, and we will create a hash map. That is simply take this character and int type. Okay, int will be simply frequency, that is simply vowel count. Okay, and next we will take care of a consonant count to count, that will simply equals to 0. Okay, and next we will take care of the, we see that let's just move. Okay, for one start. Okay, start, that will be 0, and 2 pointers, that int, and that will be simply 0 starting. Okay, then we will simply loop it while and smaller than word dot size. Okay, and then we will start this one thing. Okay, so then we will do we'll check if this character, there is character start, sorry, and new character, or you can say new word, new character equals to word end. Okay, it will start from first letter. Okay, word end, and then we will simply this new character check, we will check if is vowel, this new character, that is character, then we will simply we'll create a function is vowel that will simply check for the vowels. Okay, if it is vowel, then we will simply take this vowel count. Okay, vowel count new character plus plus. Okay, we will make increase the frequency, else we will increase the consonant count. Okay, so this will simply create the, okay, and then after we will simply end plus plus. Okay, so that was thing. And one thing, if anytime this vowel dot size, vowel count dot size becomes equals to 5, that is all vowel are there, and consonant count is greater than equals to k, that is at least k. Okay, okay, so okay, the here at least k, this means simply means not exactly k, greater than, or I have told you, okay, greater than or equals to, that is okay. Then we will simply add the num valid substring. Okay, substring, that will be simply equals to plus equals to, that is simply equals to word dot size, okay, minus end. Okay, basically we are adding total from that. Okay, the like end will be on this, and from end to the last. Okay, so it will simply have all the valid string. Okay, from that. Okay, because if the k would be there, like if you see here this, okay, if this is here, okay, if till this, okay, or you can simply take here. Okay, here are all the, okay, so if this is a valid string, okay, if this is a valid string, then from this to at last this all will be valid string according to this condition. What according to this, because we don't have to count exactly consonant count to k, because we can also take greater than k. So simply from this to last all will be simply taken as valid substring. Okay, so that's, then we will start shrinking the window. Okay, so character start character, that will simply be on the start, we will move start to the next. Okay, shrink the window, then start character, that will simply be equals to word start, and then simply if it is equals to, if is vowel, this start character, then simply if it is vowel, then simply we will subtract this vowel count start character minus minus, and anytime if this basically vowel count start character becomes equals to 0, then we will simply remove this. Okay, So what we'll do, we will remove this totally. Okay, so vowel count dot erase. Okay, erase what? We will erase this start character. Okay, okay, erase what? We will erase the start character. Okay, so okay, so this will simply erase, and if it is not, then it will simply be consonant. So we will simply consonant count minus minus. Okay, so simply we will subtract it. Okay, then at last this will simply, then we will move start plus plus. Okay, so simply it will I think it will form this, and we can simply return num valid substring. Okay, so yes, let's just run it. Okay, so we have not created this is vowel function. Let's just create it. So that will be simply bool function is vowel, that will simply get this character C, and we will simply check if we will simply return C equals to A, or C equals to E, or we can simply copy paste it. C equals to A, E, I. Okay, so that will simply be O, and that will simply be U. Okay, and you can simply, yeah, so we will simply return it, and that will simply check. Okay, let's just run it. So one thing got raw. Okay, so we have not used this. Okay, I have written this small, so let's just check it. Okay, I have not make it this like function. Okay, so I think that will simply get fine. Okay, we have not make comma. Okay, yeah, so main basically that will, this was simply compiling error. Main the logic was not bad. Okay, it's giving wrong answer. I think I have done something. Okay, I have not just, it should return this long. Okay, so this time let's submit it. So yeah, it's accepted. Okay, you can say simply time complexity, and its time complexity is big of n, and space complexity is also big of 1, because we are not, because big of n, oh sorry, because basically we are using an ordered map, but this would be basically using, so we can ignore this. Okay, so that was the basically approach.